Have you ever imagined witnessing the return of a space capsule to Earth live? Imagine the Australian desert sky being cut by an incandescent glow while a spacecraft crosses the atmosphere at more than 18,600 miles per hour, wrapped in flames and colorful sparks. It sounds like a science fiction movie scene, but that was exactly what happened on February 27, 2025, when the W-2 capsule from Varda Space Industries made history by landing at the Koonibba Test Range in southern Australia. In this video, you will learn all the details of this innovative mission that not only marked a new chapter in space exploration, but also opened doors for the future of orbital manufacturing and hypersonic research. Get ready for a journey of science, technology, curiosities, and lots of inspiration. To understand the importance of this achievement, we need to go back a little in time. The W-2 mission was launched on January 14, 2025, aboard a SpaceX Falcon 9 rocket during the Transporter-12 mission. This mission, by the way, is a perfect example of how the space industry is changing. Instead of a single satellite, the rocket carried more than 130 different payloads from companies and agencies around the world to Earth orbit. Among them was the W-2 capsule, with an ambitious goal: to test reentry technologies, conduct pharmaceutical manufacturing experiments in microgravity, and collect unprecedented data on the behavior of materials under extreme conditions. The launch itself was already a spectacle. The Falcon 9, one of the most reliable rockets in the world, took off from Vandenberg Base in California, carrying with it not only the hope of scientists and engineers, but also the dream of transforming low Earth orbit into a true industrial laboratory. Aboard the W-2 were state-of-the-art equipment, such as the OSPREE spectrometer, developed by the United States Air Force Research Laboratory, and an improved pharmaceutical reactor, part of Varda Space's plans to revolutionize drug production in microgravity. But what makes the W-2 so special? Unlike traditional capsules, which only serve to transport astronauts or cargo, the W-2 is a true flying laboratory. It was designed to produce medicines and other materials in space environment and bring them back to Earth safely and quickly. This is possible thanks to microgravity, which allows creating purer and more efficient drug crystals, in addition to testing new materials that could revolutionize industry down here. For 6 weeks, the W-2 orbited the planet, conducting experiments and monitoring every detail of its operation. Pharmaceutical reactor aboard, for example, was used to process substances that on Earth face physical and chemical limitations. In microgravity, it is possible to obtain more stable and pure molecular structures, which can result in more effective medicines with fewer side effects. Imagine a future where medicines for rare diseases or high-complexity treatments are produced in space and sent to hospitals around the world. In addition, the W-2 served as a testing platform for thermal protection technologies and advanced sensors. The OSPREE spectrometer was designed to record in real time the optical emissions of plasma formed during atmospheric reentry at speeds exceeding Mach 25, that is, more than 18,600 miles per hour. This data is essential for the development of new materials and thermal protection systems, fundamental for future hypersonic missions and for the safety of astronauts and sensitive cargo. Atmospheric reentry is, without a doubt, one of the most critical moments of any space mission. When a capsule returns from space, it needs to cross dense layers of the atmosphere at very high speeds, facing temperatures that can exceed 2,912 degrees Fahrenheit. To withstand this challenge, the W-2 was equipped with a thermal shield developed in partnership with NASA's Ames Research Center. This shield is a true armor, capable of withstanding very high temperatures and protecting the capsule's contents during the most dangerous crossing of the entire mission, the return to Earth. The moment of re-entry was recorded in impressive videos that show the capsule crossing the atmosphere amid flames and colorful sparks, resulting from the interaction between the thermal shield and atmospheric gases. After deceleration, the W-2 opened its parachute and landed gently in the desert, where it was quickly recovered by ground teams. The entire process, from launch to landing, was planned to ensure maximum safety and efficiency, demonstrating the high level of technological maturity of Varda Space and its partners. Now, you might be wondering, why land in Australia? The Koonibba Test Range in the south of the country is one of the largest test areas in the world, with more than 15,444 square miles of extension, stable climate, and low population density. This ensures safety for landing and capsule recovery operations, in addition to positioning Australia as a new global hub for space launches and returns. The landing of the W-2 was closely monitored by teams from Southern Launch, the site's operator, and by representatives of the aboriginal community, landowners, who actively participated in the mission. This involvement of traditional communities is an example of how space exploration can be done ethically and collaboratively, respecting the history and culture of local peoples. The success of the W-2 mission represents a milestone not only for the company, but for the entire space industry. For the first time, a commercial capsule returned to a commercial space, paving the way for regular manufacturing and research operations in orbit. The data collected during the mission will help improve thermal shields, sensors, and navigation systems, benefiting both scientific missions and commercial applications, such as the production of medicines, semiconductors, and other high-value-added materials. In addition to the technological impact, the W-2 mission also strengthens Australia's position in the global space scenario. The country, which already invests heavily in infrastructure and innovation, now consolidates itself as a strategic destination for companies that want to launch, test, and recover space cargo. The head of the Australian Space Agency, Enrique Palermo, highlighted that the mission's success shows the country's potential to become a launch and return hub, attracting investments and generating high-skilled jobs. And what does all this mean for you who are watching this video? It means we are living in a new era of space exploration, where space is no longer exclusive to governments and becomes accessible to companies, researchers, and even startups. Orbital manufacturing, which seemed like movie stuff, is now reality and can bring direct benefits to our lives, such as more effective medicines, more resistant materials, and innovative technologies for daily life.
The future holds even more news. Varda Space is already planning new missions with even more advanced capsules and increasingly daring experiments. Other companies are also eyeing the opportunities opened by microgravity manufacturing and the possibility of returning products to Earth quickly and safely. The 21st century space race is marked by collaboration, innovation, and the constant search for new horizons. Did you know that the W-2 mission was only possible thanks to the collaboration between different countries, agencies, and companies? The development of the thermal shield, for example, involved NASA engineers, United States Air Force scientists, and advanced materials specialists. The landing operation had the support of Southern Launch, the local Aboriginal community, and Australian authorities, who ensured the safety and logistics of the rescue. Another interesting point is the environmental and social impact of the mission. The choice of Koonibba Test Range took into account not only technical factors, but also respect for fauna, flora, and local traditions. The participation of indigenous peoples was fundamental to the success of the operation, showing that it is possible to unite cutting-edge technology and social responsibility. And we cannot forget the role of SpaceX, which with its regular and reliable launches made it possible to carry out low-cost commercial missions. The rideshare model, where several payloads share the same rocket, democratizes access to space and allows startups and universities to also participate in the new space race. The W-2 mission is just the beginning. Varda Space has already announced plans to increase the frequency of launches and re-entries, expanding microgravity production capacity. This could revolutionize sectors such as the pharmaceutical industry, electronics, and even construction, with lighter, more resistant, and innovative materials. In addition, the experience gained with the W-2 will help improve navigation, communication, and capsule recovery systems, making operations increasingly safe and efficient. The goal is to transform low Earth orbit into a true industrial park, where companies from around the world can manufacture, test, and bring back high-value-added products.
If you like this content and want to closely follow the next missions, subscribe to the channel, activate the bell, and share this video with your friends. Leave in the comments what impressed you most about the W-2 mission and what topics you would like to see in the next videos. Thank you for watching, and until the next journey into the unknown.